Hi everyone, welcome to day 17 of online instruction. We are going to talk about the volume of familiar solids today. So what volume is it essentially measures how much an object can hold. We're talking about 3D objects here. A lot of times in math, we work with objects that are 2D, they're flat. Like area, we're working with 2 dimensions. 3D, we're talking about things like cups and bowls and real-life items that hold actual amounts of substance. So when we draw these images, you're going to have to use your best imagination to picture what they would look like in real life. So the first shape we're going to talk about is something called a rectangular prism. And that's something we might already be familiar with. And what a rectangular prism is, it's like a box. So any type of pasta or spaghetti box you've had, that's essentially what a rectangular prism is. I draw the dots so you can see what the shape would be covering, like the solid sides. So a rectangular prism, it has a base. The base is the bottom part of the figure, so I'm coloring that in now. That whole thing shaded, that bottom square, we consider our base, whatever's touching the floor. And that base has a length and a width, and the entire rectangular prism has a height. So if we're referring to the length, the width, the height, and the base, you know what you're talking about now. The formula for the volume of a rectangular prism, any type of volume is equal to capital B, which stands for area of the base, times the height. So the area of our base, let's look back to what we were talking about before, that blue piece of this pink rectangular prism. The base is going to be another rectangle. So the area of a base formula is length times width. So volume here is equal to the base. The area of the base is length times width times the height. So in the example here, we have to find the volume of a rectangular prism with a length of 2 centimeters, a width of 5 centimeters, and a height of 10 centimeters. So let's draw this out for ourselves. That might help us out. So here's our rectangular prism. It says we have a length of 2 centimeters. This is not drawn to scale, but we're going to do our best. Let's make this a little bit neater. So we have a length of 2 centimeters, a width of 5 centimeters, and a height of 10 centimeters. So we're going to write out our formula again, length times width times height, or area of the base times the height, whatever you're comfortable with. And let's plug in. The length is 2, the width is 5, the height is 10. So 2 times 5 is 10 times 10 is 100. So the volume is 100. We always include our units. So in this case, our units are centimeters. And volume, since it's 3D, it's got an exponent of 3. So whatever dimension your figure is, so area is always square because there's 2 dimensions. Volume is always cubed because there's 3 dimensions. The next shape we're going to talk about is a cylinder. And a cylinder, in terms of what you're familiar with, is a soup can. Draw our dotted lines so you can see through the figure. A cylinder has a base of a circle, and circles have radiuses and diameters. So a lot of the times when you are given cylinder volume problems, you're also going to be given the radius or the diameter. The radius is the distance from the center to the edge, and the diameter is the distance across the whole thing. So the formula for a cylinder, we have the area of the base times the height. But this time, our base is a circle, and the area of a circle formula is pi r squared h. And r, if you don't remember, represents radius. And radius is always half the diameter, so don't forget that. So we're going to talk about an example now where we have to find the volume of a cylinder with a height of 12 inches and a diameter of 4 inches. So let's draw this out for ourselves. We have a cylinder with a height of 12 inches and a diameter, so that distance across the whole thing is 4 inches. So let's keep in mind, our area formula is equal to, oh, we're not looking for area. Got ahead of myself, my apologies. Our volume formula is equal to pi r squared h, where the radius now is half of the diameter. So in this case, half of the diameter, half of 4 is 2. So we have 2 squared times our height, which we were told was 12 centimeters. So let's keep going with this. Gonna move over. 2 squared is 4 times 12 is 48. Now here's the thing. Exact volume has pi in the answer. Although there's pi, you still need your units. It's centimeters, volume is cubed. So this is your exact volume. That's the answer to part 1 when it says find the exact volume. Now, finding the answer to the nearest tenths place, that's when we take this number, the 48, we press the times button in our calculator and we press that pi button. And when we do that in our calculator, that's going to give us 150.796. Since we're rounding to the nearest tenths place, we're going to round that to 150.8, include that centimeters cubed. Okay? So remember, exact volume, you keep that pi in your answer, rounded to the nearest tenth, you plug those things into your calculator, and you round it. A cone. So a cone is an ice cream cone. That's exactly what it sounds like. Let's change this color up a bit. Let's go back to, maybe we'll do a purple. Yeah, let's do purple. So a cone is an ice cream cone. It's got a height, so the distance from bottom to top. It's got a radius. And it's also got a diameter, just like a, a little sloppy to say, just like a cylinder has. The volume formula here, since the bases are not the same, we're not just going to take the area, the base times the height. The formula for this is just going to be pi r squared h over 3. So it's like we take that the cylinder formula and we divide it by 3. The example we have here is find the volume of a cone with a height of 12 inches and a diameter of 10 inches. So we're going to start off by drawing that cone. The cone has a height of 12 inches, so let's fill that in. Here we go. Height of 12 inches. And it's got a diameter of 10 inches, which means the radius is half of that, so it's 5. We write down our formula, pi r squared h over 3. So volume is equal to pi. For the radius, we're plugging in 5 squared. The height of this is 12. Divided all by 3. So when we multiply out the top, we end up getting 5 squared is 25 times 12 is 300. So we get 300 pi over 3, which simplifies to 100 pi. And remember, exact volume means pi is in our answer. So when they say the exact volume, we're going to write pi. Make sure we include our units. So we have 100 pi, this is centimeters cubed, Or no, we're talking about inches here. My apologies. Fix that. Pi inches cubed. Now when we plug this into our calculator, we're going to press 100 times and then that pi button. So when we do that, and we're rounding to the nearest tenth place, that's going to give us 314.15926 forever and ever. So we're going to write this as, rounded to the nearest tenth, 314.2 inches cubed. That's the rounded answer. Alrighty. And the last shape we're going to work with today is a sphere. Let's pick ourselves a new color. Let's do a nice, let's do a peach. So a sphere is like a baseball. Oh, that was a bad circle. Oh well. A sphere, the only measurement you have is the distance of the radius or the distance of the diameter, which is the whole thing. The formula for a sphere is a little bit wonky. Your volume formula is going to be equal to 4 pi r cubed now over 3. This is new for us. We got it cubed in our formula. And what cubed is a number times itself 3 times. So in this example, we're finding the volume of a sphere with a radius of 3 meters. So as usual, let's draw this out for ourselves. Has a radius of 3 meters. Let's write out our formula. Volume equals pi r, or 4 pi r cubed over 3. Let's fill in what we know. We have 4 pi. The only thing we're plugging in is our radius, which is 3. Let's keep simplifying this. 3 cubed is 27. 27 times 4 is 108. So I just multiplied these numerator numbers together. So we have 108 pi over 3, which simplifies itself to 36 pi meters cubed. Remember, exact answer has pi in it. Now rounded to the nearest tenth place again. We're going to plug in 36 into our calculator times the pi button. And it's going to give us something like 113.097335. Round that to the nearest tenth, and we have about 113.1 meters cubed. All right. So volume is all about knowing these formulas. It's all about understanding what the formulas mean, how we plug them in, and just multiplying with our calculators. Awesome. If you guys have any questions, make sure you reach out to me over email, over Remind, over Microsoft Teams. Just make sure you ask. All right. And I will see you back, I will see you back in 2 days for day 19 materials. Have a lovely day.